Welcome to this video 5, session 5. In this video, we will discuss degrees of data abstraction layers, schemas, logical and physical data independence. So there are 3 levels of abstraction. There is the view level. We've already talked about this. This is really the results or the result set that a user would get back from the data. It could be a listing of the whole table. It could be a filtered listing of only data that the customer is interested in. The logical level describes what data is stored as a whole in the database. And the physical level, that is the lowest level of abstraction, describes how the data is actually stored. So you can talk about hardware and software at this level. And again, the 3-level architecture here, or 3-layer architecture, we have our end users with their particular views. And a view means what data do you see, or what data comes back to the user in a result set. Again, here is our conceptual mapping here. So here we talk about how the data is actually stored and managed. And then we have our internal physical level that actually describes or gives a direction to how the data is actually managed on the host. So we can see from the picture in the previous slide, there are 3 levels of schemas in a database. And schemas an overused term, so we'll try to define it as we move forward. Typically, schema means template whenever we talk about a database. So the external level is the highest level. There exist a number of views which if we define them, they are bringing back the data that's actually part of the data that's managed in the database. And each view is provided for a user or a group of users, so that helps it in the simplified interaction between the user and the system. So essentially, the best practice would be that there is some kind of intuitive interface that allows users to enter data and retrieve data. So an example would be the user fills out a form online, name, address, and other relevant information, and then clicks submit. And that's how the user would be interacting with the database. Then there's the conceptual level schema, and that describes the logical structure of the whole database. Here, we actually want to template the data. So the tables, the columns, the relations, so the entire database is described using simple logical concepts such as objects, their properties, and their relationships. Thus, the complexity and implementation detail of the data will be hidden from the users. So the users are shielded from all of the technical details of the system. And then the internal level is the internal schema, and it describes how the data are actually stored and how they're accessed. So there's different storage in a database. There is sometimes faster storage, faster memory. So that is all part of the internal schema. At the internal level, the 3 best known models of this kind are the relational data model, the network data model, and the hierarchical data model. So the internal models here consider a database as a collection of fixed sized records. They are closer to the physical level or a file structure. Are represented of the database as seen by the DBMS, require the designer to match the concept model's characteristics and constraints to those of the selected implementation model, and involve mapping the entities in the conceptual model to the tables in the relational model. And here we can see an example of a relational schema here. So there is an EMP here, or short for employee, that's capturing employee name and salary. There are managers here, And we can see here departments, suppliers, and we can see here the entity, or eventually these will become tables, and the attributes that go along with the entity. So we have employees, and we need the employee name and their salaries. We have a manager table, and we need those manager names. We have a works in table, and we need those names and department names. We see here there's a department name, and if you look closely here, you can actually see how the the tables relate. You can see e-name here in this table and e-name here, and that gives us a link between these tables. We can see d-name here as in department name, and you can also see d-name here in the works in so you can see how these two tables are linked. So the relational schema gives us a way of not only defining the tables and the data that we need, but how they relate or link to one another. And this is the linking gives us the advantage. We don't have to duplicate data. If we need a department name for the works in, we don't have to re-input or duplicate that data. You can simply just look back to the departments table. And this figure shows a schema for the supermarket in a network model. So you can see here networking, how these entities would connect to one another. And you can see the entities and actions here, what kind of actions there are. And this, you can also glean how the entities relate to one another. And again, this gives us a model for the data we need and how they will interact. And somebody who knows the business can look at this and say, yes, that is correct. This is how our current business is working. So we can see here the data and the data flows. And in this figure shows the supermarket in a hierarchical tree, so we can get an idea of a better idea of how the data will flow within the business. So again, this is important too to understand, not only in how we want to build our data, but also in how the application that we will build works. And if we have that bottom-up type of model, it really helps to in the building of the application, and a customer can easily come in here and validate, yes, this is our current business organization. And physical models are the physical representation of the database, and they have the lowest levels of abstraction and are how the data is stored, how they deal with runtime performance, storage utilization and compression, file organization, and access methods, also data encryption, very, very important. They are the physical level managed by the operating system and the application. So the DBMS application provides the concepts that describe the details of how the data are stored in the computer's memory. And data independence. So data independence is the ability to modify the schema in one level without affecting the schema in a higher level. And there are two levels or two layers of data independence. Logical data independence is the ability to make a change in that conceptual schema without having to or causing a need to modify user views or an application program. And that's very powerful because we can make updates and then no other applications are affected. If any of you are developers, you don't want to have to recompile applications every time there is an update to a database. And their physical data independence is the ability to make a change in the internal schema without a cause or without having to modify the conceptual schema or any other application that's accessing that data.